Question number 6. Let m comma n are in with m greater than n. Use the mean value theorem to prove that 1 plus x whole power of m by n is greater than or equal to 1 plus m by n x for every x greater than or equal to minus 1. Solution. Let us consider the function f of t equal to t power of m by n. So we can write as t power of m whole power of 1 by n. Since the function h of t equal to t power of m is continuous on everywhere and differentiable on everywhere, and now we consider the g of t equal to t power of 1 by t is continuous on r plus union 0 and it's differentiable on r plus, and the composition function f of t equal to t power of m by n, the composition function of h of t and the g of t, the composition of h of t and g of t is t power of m by n is continuous on r plus union singleton 0 and differentiable on r plus, and the function when we substitute in place of t we replace 1 plus t whole power of n is a continuous on minus 1 comma infinity and differentiable on minus closed minus 1 comma infinity. We prove this in two cases. First one x greater than or equal to 0 and second one minus 1 less than x less than 0. Case 1 considered x greater than or equal to 0. Since the function f of t equal to 1 plus t whole power of m by n is continuous on closed 0x and differentiable on 0 open 0x, so we can use the mean value theorem. So what is says mean value theorem? If the function is continuous on the closed interval and differentiable on open interval, then there exists a c belongs to open interval 0 comma x such that f dash of c equal to f of x minus f of 0 by x minus 0. This implies what is f of c? Here the function is 1 plus t whole power of m by n. When differentiation m by n 1 plus c whole power of m by n minus 1, since the differentiation of x power of n equal to, since the differentiation of x power of n equal to n into x power of n minus 1 equal to f of x. Here the f of x equal to 1 plus x whole power of m by n minus f of 0. When you substitute 0 into this function, 1 plus 0 whole power of m by n, that means 1 by x minus 0. That implies m by n 1 plus c whole power of m by n minus 1 equal to 1 plus x whole power of m by n minus 1 divided by x. Say it is as a 1. Since m comma n belongs to n and c greater than 0 and m greater than, all these are given by hypothesis. This means m by n minus 1 is greater than 0. So m by n is greater than 0 implies 1 plus c. See 1 plus c, here 1 plus c is greater than 0. So 1 plus c whole power of m by n minus 1 is greater than or equal to 1. So this implies, so when you multiply by m by n, because both are m by n are positive, so when the inequality will never change. So m by n into 1 plus c whole power of m by n minus 1 is greater than or equal to m by n. Therefore 1 plus x whole power of m by n minus 1 by x equal to m by n 1 plus c whole power of m by n minus 1. This is from 1. Okay, this is greater than or equal to, this is greater than or equal to, we know that this is greater than or equal to m by n, this is greater than or equal to m by n. So that implies 1 plus x whole power of m by n is greater than or equal to 1 plus m by n into x. This is the first case. Now we prove the second case. Case 2, minus 1 is less than x less than 0. Since the function f of t equal to 1 plus t whole power of m by n is continuous on closed 0 comma x and differentiable on open 0 comma x, whereas x is running from minus 1 is less than x less than 0. So we use the mean value theorem. Since the function is continuous on the closed interval and differentiable on the open interval, so we use the mean value theorem. There exists c belongs to x comma 0 such that f dash of c equal to f of 0 minus f of x by 0 minus x. This implies again the derivative of the function 1 plus t whole power of m by n equal to m by n 1 plus c whole power of m by n minus 1 equal to, what is f of 0? When you substitute in place of t equal to 0, 1 plus 0 whole power of m by n, that equal to 1 minus f of x. Here the f of x equal to 1 plus x whole power of m by n 0 minus x. That implies m by n into 1 plus c whole power of m by n minus 1 equal to Here the minus and minus. So when you multiply with minus, we get it as minus 1 plus 1 plus x whole power of m by n by x. So that implies x into, so here this is the value, and that implies when multiplying with x into m by n into 1 plus c whole power of m by n minus 1 equal to minus 1 plus 1 plus x whole power of m by n. Since we know that the c belongs to x comma 0 and x is running from minus 1 comma less than 0, that implies c is also running from minus 1 less than x less than 0 and x is less than c less than 0. Since c is in between x comma 0, so that implies when you add 1, so 1 plus x greater than less than 1 plus c is less than 1. Here we are adding 1 for this inequality. That implies, so again, so here we know that m by n greater than 1. That implies my m by n minus 1 is greater than 0. So this is a positive quality. So 1 plus x whole power of m by n minus 1 is less than 1 plus c whole power of m by n minus 1 is less than 1. Right? Because the quality, this inequality is positive, this value is positive, so the inequality will not change even though we raise the power m by n minus 1 and multiply with m by n. So we multiply with m by n since m by n is greater than 1. Okay, since m by n is greater than 1. So m by n into 1 plus x whole power of m by n minus 1 is less than m by n into 1 plus c whole power of m by n minus 1 is less than m by n. Here we multiply the m by n with the whole the inequality. And here x is less than 0. When we multiply with x, this inequality will change as a less than into greater than. So m by n into x into 1 plus x whole power of m by n minus 1 is greater than m by n into x 1 plus c whole power of m by n minus 1 is greater than m by n into x. Since x is less than 0, the inequality is changed. That implies m by n into 1 plus x whole power of m by n minus 1 is greater than, what is this value from 2? M by n into x into 1 plus c whole power of m from 2, we can replace into minus 1 plus x whole power of m by n is greater than m by n into x. Right? That implies, now we add the plus 1 into total value. So here we are adding the plus 1. So here adding the plus 1 and we are adding the plus 1. So plus 1 minus 1 get cancelled. The remaining value is 1 plus x whole power of m by n is greater than, we are adding 1. So 1 plus m by n into x. Hence 1 plus x, hence 1 plus x whole power of m by n is greater than or equal to 1. 1 plus x whole power of m is greater than or equal to 1 plus m by n into x for every x greater than or equal to minus 1. This is the problem number 6.